Okay. You can see the screen, right?
Yes.
Okay, thank you so much. Okay, yeah, so I thought that I will structure this talk in the way that I will share my experience in both ways as a PhD student and PhD candidate. The difference between student and candidate, basically, when you're a PhD student, you have your coursework to finish, and then you have qualifying exams to pass. And then as soon as you're done with that part, you become a PhD candidate and basically can focus on your research solely. And then as a PhD intern, how it goes, how to prepare, when to apply in that direction. So a little bit about myself. In 2015, I received a bachelor in science, in computer science with a focus on informatics and international relations in St. Petersburg State University, which is in Russia. Then in 2016, I joined a master's program in our university in UMass Boston. And then as some of you may know, in 2017, I took CS 670. And then decided to proceed with my PhD with the focus on AI and machine learning. In 2018, I passed my qualifying exams, and then 2020, major milestone, one of the major milestones in my PhD career was that our research work was admitted to one of the top conferences in knowledge discovery and data mining, KDD conference. And in the summer of 2020, I got a chance to present our work on the virtual conference. Then I also, that's the same summer, received the fellowship support from Oracle through our university. In 2021, I got a chance to get a summer internship at NVIDIA, which was really nice and cool opportunity. 2022, 2 publications, AI in Medicine and IEEE Intelligent Systems journals. Also this summer, I got an opportunity to be a PhD intern at Meta. And fun fact about me, the same summer, I did a cross-country road trip, which was 8 days long, and in total there was 3,999 miles we traveled with me as a sole driver. And you can see here is a picture of me standing somewhere in the mountains of Colorado. Really nice trip. Yeah, so to basically, the theme of my research and the theme of my thesis is machine learning application to critical topics in health informatics. And I had 3 projects. One of them was on cancer subtyping. Second one is a collaboration with our nursing department. And it was on identifying fall risk factors among senior adults. And finally, it's a collaboration with Professor Scott Crowther from another university, and there we were working with activity recognition data sets, and we were approaching the problem of fairness mitigation in machine learning, and basically how to make a model more fair. And some of this research was supported in part by College of Science and Mathematics, the doctoral research fellowship through fellowship support from Oracle. So if we're talking about, well, more deep dive and a kind of like higher overview of the project. So one of them, again, class cancer subtyping, and cancer subtyping can be viewed as the clustering problem of machine learning, where it's an instance of unsupervised learning where we're giving data points and we don't really know the true label or true assignment or ground truth of these labels. So basically we don't really know whether the person we're looking at, he has cancer of type 1, 2, or 3. And if you don't aware of this, even if even in one type of cancer, like ovarian cancer, right, there are multiple subtypes, and depending on what subtype a person or a patient is assigned to depends his further treatment and the success of his treatment and his survival predictions. So basically, if we put the person to a correct subtype, or we assign him to a correct cluster, then he has more chances to receive a better treatment or to react in a good way to particular chemotherapy or any treatment protocol which would be applied to him. And an actual problem, so the problem we were trying to solve is we're given a data set of gene mutation data. 0, so basically it's a binary data. 0 stands for genes which are non-mutated, and if a gene was mutated, we have 1 in this place. And we have a lot of genes, right? So for ovarian data set, I believe it was a little bit less than 10,000 genes for one particular person. For lung cancer data set, which we looked at, there was almost 16,000 genes, which were either mutated or non-mutated. And so basically, that means that we have a space of dimension either 10,000 or 16,000, right? So it's a multi-dimensional space. And somewhere there we have points which are our patients. And then what clustering does is based on the distance, right? It will group your patients or your data points together. But as you can see on the picture, sometimes it may happen that some of the data points, they are far away from the correct cluster because connecting bridges or connecting points were not collected during the data collection stage. Why? Well, it can be costly, first of all. Second of all, we just may have those particular patients, right, in our data set. So how to deal with this? And we proposed a solution which required GAN. And what GANs do, they take your data and they try to mimic, and they learn distribution according to your data is distributed, and then learns the distribution, and we can draw samples from this distribution and then rerun clustering algorithms and get better results. The next problem is that how do they know that the sampled point from the GAN learned distribution is a useful one? That's the next problem we approached in this research project. That more on this, how we approach this and what did we do, you can read in the paper, or I'm happy to discuss this after the talk or during my office hours. Second project, full risk assessment through a synergistic multi-source DNA learning model. So in this projects, we were basically targeting full risk assessments in older population, and falls are the second leading cause of accidental or unintentional injury deaths worldwide, actually, and in this is the sixth leading cause of deaths in the older population of the United States. So that's a serious problem, and the way we approach this task is, first of all, we worked in the collaboration within our nursing department, and they already performed the study and they collected some data, but that data was from different modalities. So it was text and it was numeric statistics, for example, gender, age, there was pain levels. And what we were trying to look at, we want to utilize the complementarity of these different multiple sources of data to reach the consensus and see basically what new features we can identify which are impacting, which have a major impact on falls in older adult population. And well, the third project is with activity recognition, but not solely focused on this, but that was a real world data set, which was really interesting to work with. So the problem here is we're given the data set of activity, well, of sensor reading. So in activity recognition data set, we have sensor readings from both wrists, from both ankles and hip, and collected from different people while they were performing different activities, running, sitting, walking, and so on. So basically each person was our different data generator, right? So we have a collection of data set from different people. And of course, when training, your classifier will perform differently on every person, right? So even though for the whole data set, you can reach an accuracy of like 90%. If you look at statistic of prediction for every single person, it will vary a lot. It may be like 75% accuracy from one person and 99% accuracy for another person. Why? Well, there are multiple reasons. Well, some people are taller than the average people, right? Some people are not that active. Some people, they work out a lot, so they run faster, for example, right? So those are impacting factors. And what we were trying to do in this work is trying to mitigate this fairness problem. And what we did is that there were, at that time, a recent work of mode connectivity was published. So what mode connectivity is that researchers discovered that local minimas in the loss space, they are connected through paths of similar basically performance, right? So what we did in this work, okay, let's connect those local minimas and then try to see if on this path there is any model which perform more evenly on the people in our data set. So that was an interesting work. So now basically major question for people who are now in master program or in their undergrads, right? Why do you want to pursue a graduate degree? So in my case, well, I got my bachelor degree. I was working for 2 years. I started working while I was still pursuing a bachelor degree. I started working in the Research and Design Institute. And we were basically working with the railway transport, and some of the projects which were in the beginning, they were easy, but the more we go deeper into the problems which we acquired, like the more complicated those projects became. So for example, at some point there was a task that, okay, based on the collected data, can we predict a maintenance period for a freight car? So basically the problem is their wheels got distracted by the uneven roads, right? So can we predict when the next maintenance period can be? So, and at that point, I realized that I don't have enough knowledge and I don't have that broad enough knowledge, and I don't know how to approach this task efficiently. I had some ideas, but I didn't know what to do exactly. So there are two options for me. Either I'm gonna do this by myself, so through like online courses or reading multiple tutorials or doing workshops, or I go back to a graduate school. I decided to pursue the second option because why not? I get a chance to acquire broader knowledge, not only on the particular topic I was interested in, but also get some interesting insights on other aspects of CS. And then when I realized that I want to pursue machine learning and AI direction in my career, I transferred to PhD, and that was an opportunity to acquire a deeper understanding of the topic. So what are advantages of pursuing a doctorate degree? First of all, freedom. Basically, you're free to choose any approach, you're free to choose any coding language, you're free to choose any topic you want to work on. Well, you are bounded by collaborators that your professor can find, but at the same time you can work, you have a university to work with, you can find people, you can find other professors, and you can work from there. Well, you do acquire an expert level knowledge. You attend different conferences, you read multiple papers which are published yesterday, and you understand the direction in which the field is going, and you are on staying up to date constantly. And again, collaborating with different people. You can collaborate with your university, or you can collaborate with professors in other universities, you can collaborate even with industry researchers. And it all depends up to you what you want to do. Some of the challenges, well, today, especially in machine learning and AI, it is becoming harder and harder to compete with the industry. Such big companies as Google, DeepMind, right, NVIDIA, Meta, they all have their research departments, they have their machine learning researchers, they have their data scientists, and it's harder and harder to compete with them because they have more resources, they have access to cloud computing, they have their own supercomputers. So it is up to you what you want to do, whether to find an incremental improvement on some existing methods, or you want to find some specific interesting application, right? So you're trying to adopt to the situation you are in, but it is getting harder and harder to compete with the industry. Second challenge, combining research with the course load. So it comes from me as when I was a PhD student. We are required to attend classes, and sometimes you're also a TA, so you have less time for your research, but it's still, if you want to make progress, you need to find time for your research. Publishing and sharing your research, it is hard, especially in the beginning, and especially if you're a non-native speaker, non-English speaker. You're not only required to write a paper in the language you are not native speaker in, right? But you also need to make sure that the ideas that you want to deliver are delivered through the paper you wrote. And sometimes it is hard because the way it works is you submit your paper, and then there is a peer review stage that researchers from multiple other universities, you don't know them. Usually it's a double blind review process. So they read your paper and they decide whether it's convincing enough to be published or not. And of course, it solely depends on them, whether they spend 5 minutes on your paper or an hour on your paper. It is your job to make your paper clear from the beginning and keep it consistent. So it is a learning curve, and you will struggle eventually in the beginning, but you'll get to the point where, okay, I know how to do this, and there are less iterations for your next papers to be accepted to the journal, conference, or a workshop. Differentiating between valuable and unreasonable feedback. Sometimes the feedback very not questionable, but you see that the person completely missed the idea, and you're trying to advocate your method or your solution which you propose in the paper again, or if this feedback did provide you valuable insight, you do need to incorporate it either right away or just continue developing your method and rerunning experiments. Sometimes you'll get reviews which are completely opposite of an opinion. For example, I had like a couple of situations where reviewer number 1 writes that ideas are clear, language is fine, or like grammar is correct, or like the topic seems convincing. And the reviewer number 3 says nothing is clear, authors missing the point, and so on and so forth. So yeah, so that is, at this point you're like, okay, what did I miss? How can I improve my purpose so that nobody misses the main topic I'm talking about? And then qualifying exams. Qualifying exams, they are important. Take them rather sooner than later. Make sure you're prepared. And then, so basically, why qualifying exams are important in our university? It is when you pass qualifying exams, you can focus on your research. Basically, you can take CS 899, which basically class for working on your dissertation. So you will get that time which you can dedicate solely for your research. But they are challenging, they are hard. One suggestion which helped me, find a fellow PhD students and prepare together. I was preparing with my lab member, Hafe. Hafe, thank you so much. You helped me a lot. And we both pass. So yeah, and approach professors, ask a lot of questions. That always helps. Another topic which I want to focus on is financial support. So sometimes your professors have research grants to support you. Sometimes you need to take a TA positions. What else you can do is you can apply for research fellowships. For example, UMass Boston provides CSM Doctoral Research Fellowship, which are supported by Oracle and other sponsors. You can apply to industry fellowships. So Google, NVIDIA, Meta, Adobe, a lot of companies, Microsoft, IBM, they do have PhD fellowships, which you can apply to. You do require to provide your CV, talk about your research, find some letters of recommendation. So it is a work to prepare your application, but it's worth doing that in multiple ways. So first of all, money, you'll get funded. And then second of all, it is nice to have this on your CV, and as an alternative, you may be asked to invited to continue your research as a PhD intern in the company you apply to. NSF provides a lot of fellowships. And another part is internships. So if you work in the summer, you try to get a paid internship. Most of the internship in CS are paid. So it's not that hard in the sense of to find a paid internship. And they paid a really nice sum of money for summer so that you can cover the cost of living or the cost of healthcare. So now internship. So why would you want to take an internship, especially if you're a PhD student? Well, first of all, you have a chance to practice what you've learned, right? You're focusing on machine learning, you're doing research in machine learning, but industry, for example, is always different. And they have a specific task at hand. And you kind of get a notion of, okay, what is now a leading topic in machine learning for industry and what I need to be focused on, whether it's distributed learning or metaverse is now popular. Second, you're not required, well, basically it's up to you where you want to work, continue to work, but internship is a really nice way to try different fields, whether you want to work in industry or in national labs or in academia. So you're doing PhD, you're trying out academia field. You can find national lab and do internship there and see how things go there. Or you can work as a PhD intern in industry and see how researchers and what go about there, what questions they have to solve, and what are they doing there. It's a short-term commitment. You're there for 12 weeks usually, and you're not obliged to stay. So if you don't like the team or you don't like the company, you don't require, right, to struggle there any longer than 12 weeks. Returning offers. So these are nice way to get yourself a future full-time offer or a future summer internship. If you really like the team or really like the company, you can ask to come back, and if you perform well at your internship, are always welcome to come back depending on financial situation. For example, now we're in the recession. As far as I know, all full-time returning offers are freezed. So there's really interesting topic to discuss. Lessons learned from my internship. So basically, start preparation in advance, way in advance. It may take, well, depending on your level of readiness, right? It can take you up to a year to make yourself comfortable in interviewing process. But I do recommend to start preparation in advance and applying in advance. Why? Well, because typically, for example, FANG companies, right? So our major companies like Google, Amazon, Facebook, they fill out their, especially PhD research internships by December, they're pretty much filled up. So if you apply in August, you do have chance to find a better team and get to a better position. But usually they're quite filled up by December. We're talking about Twitter, for example. What Twitter did previously is they collect their applications throughout the fall semester. So basically they have a deadline in December 1st, I believe. And then starting from December or even a bit earlier, they start approaching you if they're interested in you. And then December and January, you try to pass their interview. And then in the late January, you have a chance to get an offer for a summer internship position. So if you are targeting a bigger companies, apply early. If you're targeting a smaller companies, of course, probably January, start to look for January application. And do take advantage of referrals. What referrals are? If you know somebody in the company, ask them to refer you to a specific position. Why? Because it speeds up your process and your CV is not going to be lost anywhere, and recruiter get a chance to see your CV, right? It does speed up the process. So do take advantage of referrals. They're good for you and they are good for the person who is referring you, because sometimes they're getting paid. Usually what to expect when interviewing? Well, standard interview, you have 2 or 3 phone screen interviews, which are usually focusing on the coding assignments, right? So you're given a task like array-based, string-based, doesn't matter, like find the biggest running sum or something like that. So lead code is the best way, which prepares you for this code screen interviewing. 2, 3 phone screens, usually 2 if you're very good at 2 phone screen interviews, that's it. If you're wasn't okay in one of them, it may require them to schedule you a 3rd phone screen, or the 3rd phone screen sometimes is scheduled to talk with the hiring manager or with your future manager. So don't be discouraged if you scheduled a 3rd phone screen. So for PhD internships, sometimes you have an extra step. So for example, for a meta PhD internship, there was a second step. So passing phone screen does not guarantee your internship. It's you need to be team matched. So, and when you're team matched, then you're getting an offer. Team matching interviews are usually you're talking with your future team you're gonna work with. They ask you questions. It can be system design questions. They can be specific questions, for example, machine learning related questions or questions of your previous experience. Doesn't matter. Ask your recruiter. They will update you more on this. So again, code related questions, your background, some puzzle questions. Sometimes the people like to ask some not specifically coding related questions, but some puzzle questions. They just want to see how on your third process. Usual and typical question they ask during the interviews is tell me about yourself. So what I recommend is for you to prepare like a 5-minute answer for this question in advance, so that you don't think while you're presenting this answer. It just helps you to basically to boost your confidence on the interview when you have a prepared answer to the question, right? And try not to repeat your CV, so try to include some interesting facts about yourself. Think about how you can tweak your answer in advance so that it shows that you're a good fit for this particular company. Why did you become interested in this company? Or maybe they have some principles, right, which align with your vision on the future of AI, machine learning, or the whatever field you're applying to. And again, keep it short. 5 minutes is more than enough, because if you're keep it long, it takes your time from the coding questions, and you don't really want to take time from the coding questions. Final questions, the way the interview ends. Do you have a question for me? A typical question. Yes, you do. You do have a question for them. Why? Because it shows your interest in the company and the position. When they're choosing between candidates, they have a lot of similar candidates, right? If you don't have questions for the person, for a representative of the company you're interviewing with, well, why don't you have questions? Are you not that interested in this company? Do you really want to work there? So you do have questions. You can ask any questions you like. What are your typical day at work? What were the previous internship projects, right? Or what are the future internship projects will focus on? Ask anything you like. It's your opportunity. If they can't tell you anything, they will not, and they will make you aware that, okay, I am not allowed to talk about this. Or maybe you can sign an NDA agreement before this interview, and then you can discuss any topics you like. So some lessons learned, well, again, ask for referral. It speeds up your process of interviewing. Treat each interview as a discussion on the topic. You will, well, it is anxious to be interviewed, but really treat it as a discussion. Ask any questions. Ask any questions that will help you to solve the problem. Don't be afraid, and keep talking constantly, basically. And again, you're also interviewing them. If you see some red flags from those interviewers, well, and you don't really like the way they treat you, do you really want to work in this company, right? Is this the typical behavior in this company and you don't really want to deal with it? Or how's it even going? Like, so you're also interviewing them. How to prepare, again, lead code for coding questions. Lead code is your, well, first place you're gonna go to. You can always use discussion section for recently asked questions. So if you go to the discussion questions, you can sort it by the date and filter by the company. And sometimes people post what questions they were asked during the phone screens. And if you don't know where to start, Google blind 75 lead code questions, start with them. They will help you to cover all topics which are required for interviewing. If you are a PhD interviewing for PhD, you will most likely be asked about your projects. I would recommend you to write a small summary of your projects in advance, again, that boosts your confidence, and then you can tweak those summaries in the way that you know what questions they will ask you and prepare yourself to answer those questions, right? Know your basics. If you're PhD students, if you're PhD in machine learning, know machine learning foundations. For a code related questions, you know time and space complexity. They can ask you about multi-threadings and so on. In the research related questions, sometimes they ask about what competing methods you tried, right? Fundamentals, or for example, okay, here you're dealing with clustering. What about like how clustering works, right? What distances, right? So what distances there are. So be prepared for those types of questions. Well, use Google to your advantage. Search what to expect when interviewing at Amazon, Fang, Meta, Liberty Mutual, and so on. Google will always provide you with some insights. And again, ask your recruiter. Recruiter is your first person of contact, and ask your recruiter what to expect. Usually they send you information in advance, but if you still have questions, please don't hesitate and reach out to them. It's in their interest to help you as much as they can so that you succeed. What to expect from your internship? Well, again, short-term projects. Well, typically it's not a major project which the team is working on. It may be a part of this project, but if they have like a nearby deadline approaching, they won't give you this important project, right? You will be giving a small project, and they will explain you in the beginning of your internship what you're going to be focusing on and what to do. Structured outline but clear deadlines. That is something you would like to see presented to you by your manager or your mentor. If they don't have it, then spend your time 2-3 days on defining those clear deliverables, right? Okay, in 3 weeks, what do you want to see from me? In 4 weeks, 6 weeks, and so on, because you will get a midpoint review and a final review. So by the midpoint review, how you're performing so far, whether you get any deliverables, whether you're on the schedule or not. So you do want to know what they expect from you. And the best way to do this is to prepare a structured outline of deliverables with the due dates and so on. Make a list of initial questions. What do you have? And try to find an answer in provided materials first. That shows that you are capable of approaching the project by yourself. And then if you are not able to find any solution in the provided material or any answer to the questions, or you're still not sure whether you understood everything correctly, then approach your mentors or managers and explain clearly, okay, I'm trying to approach this problem. So far, I figured this, this, and this, and I am stuck, have trouble of identifying this in my project, or I have trouble to figuring out how to do this particular problem. So create a clear explanation of what you know so far, where you're stuck, and what you want to achieve in the end, and explain that you're getting stuck in this particular part and how can you help me. Basically, if your manager doesn't know how to help you, he will refer you to some other people. It is best if you have a presentation in your final week or sometimes in the end of your internship. Why? For visibility and for your team to make, basically to make an imprint on your team. Here's what I did. That was a really nice project. Here's what I learned. Here's how I helped my team to solve this particular problem. and why am I a valuable candidate, right, to be hired or to come back next summer. Final, remember to use all benefits the company provides. Sometimes companies have online learning materials which are not free for general public, but they are free for you as an employee. Travel, commute reimbursement, activities for intern, make sure you attend them. It is fun activities. You get to know a lot of people, good for your networking. If you're an F1 student, sometimes some company, they reimburse your CPT payments. So we are required as an international students to be registered for a CPT course, and we pay for it. Sometimes company reimburse you that. So make sure to use all the advantages you have. So now I'll talk a little bit about internships at each company. Again, internship at NVIDIA, how did I get it? I applied during virtual conference at Europe. One of the benefits of being a PhD student, you are attending different conferences. Those conferences, they do have representative for companies, and this sometimes is an alternative to referrals. So basically you talk directly to recruiters, you give them your CV, and then they look at your CV, and you're getting a follow-up email with scheduling your phone screens. During that internship, I get a chance to collaborate with multiple teams in NVIDIA to assist in dynamic boost enhancement to cover a wide range of workload. I did sign an NDA, so I can't talk about all the details I was doing there, but if you have questions, I'll try to answer as much as I can. I took advantage of free access to Deep Learning Institute. So for example, I took multiple courses, which were, some of them were really easy. Some of them were something new to me. For example, CUDA Python was a really interesting course, very challenging. Participated in NVIDIA intern hackathon. So that was a hackathon solely for interns, and it was focusing on natural language processing with Riva API. That was really cool and really valued that knowledge I received there. Lessons learned during that internship, communication is important. I think communication is what helped me to succeed a lot in that project, because the project was not really clear from the beginning, and through that communication and collaboration with different people, I was able to deliver a really nice solution to the problem. Don't be afraid to reach out to different teams. Even if your manager doesn't know whom to connect you with, go to Slack channels or whatever they use for collaboration between employees, right? Reach out to everyone, and they're always happy to help you, especially if you're intern. You will find a person who will help you. And that was the time when I realized that a clear project schedule is a must-have. So it is better to have that schedule that, okay, you have week 4, you need to deliver with this. You have week 6, we have a midpoint review. I would like to see this and this and this by the midpoint review. Now internship at Meta. How did I get this? I emailed to my recruiter with whom I stayed in touch. So I did try to get this internship at Facebook and Meta a couple of times, unsuccessfully, but I did stay in touch with my recruiter, and I emailed her some from time to time. And from time to time, she reached out to me, right? So we're getting this activity for like future possible interns. Would you like to attend this, ask a lot of questions? They will help you. I was working PyTorch distributed team. So PyTorch distributed team basically focuses on solutions and approaches how to train huge models on multiple GPUs. So if you know or you don't know, sometimes model cannot fit into one GPU, for example. And then we need to split this model among different GPUs or different nodes. One node is, for example, like 8 machines. So there is a specific framework how to do this. In PyTorch, there is a distributed data parallel. Distributed data parallel focuses on distributed data. So your model is copied among different GPUs, but those model instances, they train on different data. Fully sharded data parallel, which I was working with, it focuses on actual model parallelism. The main problem which they were facing is during the training, those shards needs to communicate somehow, right? And if we're talking about communicating in one node, okay, we can connect GPUs with NVLink and the communication is going to be fast. But if we're talking about multiple nodes, we cannot connect multiple nodes solely with NVLink, or we have no resources, or sometimes we don't have access to faster connections. So then communication between different nodes becomes a bottleneck. So there are different communication algorithms which target that bottleneck. And my project was focusing on implementing two of them and see advantages and disadvantages, where it is feasible to do or not. Really interesting projects, enjoyed it a lot. Lessons I've learned: don't be afraid to adjust the proposed project plan according to your preferences or skills. For example, what I would do with Meta project is I was given two starting tasks which were not related for the project per se, but what I would do now is I would ask to change them. Okay, for example, I do need to run experiments. How about I spend the first 2 weeks on setting up my baseline, setting up my environment? How about we substitute two existing tasks for creating a baseline? Don't be afraid of asking about this. It is essential to make yourself visible in a large corporation. You want people to remember you. If they remember you, they will more likely to come back to you in future. Try to make as many connections as you can and stay in touch with your recruiters and managers and fellow interns you met. You don't know where your friends are going to end up with. You can also always ask them for referrals. You can open your startup with them and so on and so forth. Don't lose this opportunity. That's why it's essential for you to attend different internship events where you get the chance to meet your fellow interns working on different problems in the company. And finally, ask for a time to set up your environment so that later, right, when the deadline is approaching, you don't need to lose time on like tweaking something that wasn't done in the first place. Here are some resources to stay up to date. For example, do use your conference and journals to stay up to date on where your field is developing, whether in the new approaches out there are there. NVIDIA GTC, if you're interested in AI and machine learning, computer vision, Omniverse. NVIDIA GTC is a free online conference held by NVIDIA. It's 2 times a year, free registration. Attend. You can always go back and view, look at different videos or presentations or talk at the NVIDIA. Really interesting conference. And some of the resources for, fortunately, women only, CRAWP, Anita Borg community, they do organize some meetup conferences where you get a chance to talk to researchers, experts in the field, and then can provide your feedback on your CV, on your research, on the direction where to go to. For example, do you want to join industry or academia or national labs? They can answer questions in relate to that. Lead code. Do your lead code every day. Team Blind, Google me. Google, if you don't know what Team Blind is, Google it, thank me later. Basically, for example, now we're in the recession, a lot of companies are in hiring freeze. Team Blind gives you an insight which companies are in a hiring freeze and which are not. YouTube help you to find talks from the conferences, from the workshops, do utilize YouTube. Medium, a really nice place to go to. For example, Medium has some blog post on how the process of interviewing to Meta for a PhD internship was in 2 posts, and some other interesting ideas. Finally, asking for help. Asking for help is important. It will speed you up in your process. You are solely responsible for your career development and growth. So do ask for help, everyone you can. For example, ask to discuss your research and receive a feedback, especially in the beginning. You receive a feedback in different views on the problem, and you try to understand how to approach one problem from different perspective, and that helps you in your research. Attend poster sessions. They give you exposure. You can find possible collaborators. You do receive a feedback for your research. Reaching out to open source communities is helpful. For example, PyTorch is an open source communities, and some interns where they're continuing their research as a PhD intern at Meta because they reached out to PyTorch community some time ago, and they were asking constant questions, and then they were starting the collaboration. Referrals help you speed up your hiring process. Asking for help with your idea project code saves you a lot of time. Asking for support help you to overcome hard times and not be discouraged. You didn't pass the phone screen. Your paper got rejected. You needed that support. You need friends. You need your family. They help you to overcome those struggles. Use all available resources you have. For example, our university can help you with CV and prepare you for behavioral interviews. They do have a really nice resources, so please utilize our university's help. Connections at LinkedIn. The worst thing that can happen, they just tell you, sorry, I don't know you that good, I cannot refer you, but it does not hurt you. Meetup and company organized events also important. For example, I did get a phone screen with Twitter because I attended one of their events in Boston, and then I mentioned it in my application. So I think that helped. So that is it. If you have any questions, please feel free to answer or to ask them. Happy to answer.
Hi, Olga. I have a question.
Sure. Hi.
So how did you get in touch with the recruiter for Meta? Like, where did you find them?
Sure. So what happened is at some point in the summer, I got email or from the recruiter that would you like to try interviewing for the opportunity. I think they found me through the LinkedIn, so keep your LinkedIn updated. Sometimes again on the LinkedIn you can find recruiters there, or conferences you attend, or through your connections. That helps you. So yeah, so she got in touch with me first. I didn't pass that time, but you have your correspondence in the emails, right? So then next year I reached out to her, and at that time she already finished with PhD for her positions, but she did recommend me to another recruiter, so I did get a chance to interview for another position. And then finally, the third time, I basically just reached out to her again and told her that, hi, I'm available for this position, do you think we can start interviewing or something like that?
Okay, thank you.
Sure. Okay, if you don't have any questions, thank you so much for attending. If you let me stop recording.